All right, guys, we're going to have ourselves a long video for this one because it's a very interesting problem. So we have Jorge. He walked from home to the bus stop at an average speed of 5 kilometers per hour. He also immediately got on his school bus and traveled at an average speed of 60 kilometers per hour until he got to school. They gave you the total distance from his home to school, which is 35, and they told you the total time of his walking and his bus time, which was 1.5 hours. The question for you guys is, how many hours did Jorge cover by walking and by traveling on the bus? Well, the first thing we have to do, guys, is we need to label our variables, our x and y. Well, you could say the x could represent the walking to bus, wouldn't you? Could that be how much distance it was from home to the bus stop? And what about the y? Could the y be from walk distance from bus stop to school? So maybe those could be our variables representing. So let's set up a picture. If I were to set up a picture for you guys, let me try to make a straight line here as best as I can. Didn't work. There's a little trick this thing gives. There you go. Perfect. Well, we could say this is the beginning, which could be the house. We could draw a nice little house here. Nice little house. And now we have the student, Jorge, who walked all the way to the bus stop. Let's just say it's right here. This is the bus stop, right? So Jorge walked all of this at a speed of 5 kilometers per 1 hour. That's how fast he was walking. Now, from then on, he went from the bus stop all the way to the school. Right? And we know he went, well, let's try the school here. A longer house, you see, school. And he traveled there at a speed of, what was the speed? 60 kilometers per hour. So 60 kilometers every 1 hour. Okay, guys, so let's create two equations here. One equation could be about what, guys? Didn't we just talk about distance? And our other equation could be actually about time. So did they give us a total distance, guys? Didn't they tell us how much was it? It was a total of 35 kilometers. So we know this equation is equal to 35. Do we know how much we walked? No, we don't. But could we give it a letter? How about we give it a letter? Well, you said X, right? How about we give it an X? That's for walking. And the Y was for the bus. Now, what about time? Here's where it gets interesting. Because we want to focus on the time walking. The time walking. And also the time on the bus. But you know what's the problem? The problem is that they gave us speed, not time. Well, I'm going to give you a little bit of a physics quick lesson here. We know how much this person walked as an X. And we know how fast this person was going. 5 kilometers over 1 hour. Well, guys, isn't the X also in kilometers? Because it's how much they walked? Well, guys, because of that, we cannot have a fraction over another fraction. So we multiply for what is called the reciprocal. 5 kilometers. 1 hour equals 5 kilometers. What happens here, guys, is that these cancel. And we're left with is actually just the X over 5 kilometers. I needed to show you this, guys, because it can be confusing how I'm going to set the next problem. So with this idea, guys, so we're talking about the bus. It's going to be Y over, what was the speed of the bus? You guessed it, Y over 60. So here's the equation for the time. It's going to be X over 5 plus Y over 60. And what was the total time we traveled? The total time was, you said 1.5 hours. So let's call it 1.5. All right. Is everybody okay? Good to go. Now, we know how to do this by now, guys. We have two equations. I want to eliminate one. Which was the easier one to eliminate? I'm going to go with the X in this case. Now, notice that we need the same number. There's a 1 here. There's a 1 there, but there's a 5 at the bottom. So to get rid of fractions, guys, what do we always do? We multiply everything by the bottom. So we just want to get rid of the 5 here. So let's go ahead and do this. Times 5 on both sides. That will be 5 times 1 is just a 5x over 5 plus 5y over 60. And what's 1.5 times 5? That's 7.5. Okay, so I'm going to write this down over here, guys. Once again, we still have the 1x plus 1y equals 35. And guys, what's 5 over 5? That's right, it's just a 1. 1x, we can actually simplify this to 5 over 60. Isn't that 1y over 12 equals 7.5? All right, guys. We're almost done. Remember, we still need to make it opposite. We multiply everything by a negative. And actually, why don't I do this one by a negative? Multiply everything by a negative. And that's just going to give me negative 1x minus 1y is equal to negative 35. So the x's cancel, guys. I cannot combine these two because remember this is an over 1. But guys, what can I turn? Can I turn this 1 over 1 into a 12 over 12? Isn't that the same thing? Look at that. Now we're talking. What's negative 12 plus 1? That will be a negative 11 12y equals, well, what's 35? I'm sorry, 7.5 minus 35. That's a negative 27.5. It's getting a little crazy here, guys. I understand. But just give it a minute. Give it a minute. Now, if we multiply by the reciprocal, minus negative 12 over 11 times negative 12 over 11. Well, this times negative 12 will give us 330. Divide that by 11 gives us actually 30. Guys, you found your y. Your y is 30. What did we say y was again? The distance going to school. So this whole thing, guys, is actually 30. You found the total distance the bus went to school. Now, if the total distance, remember, the total distance was 35. Well, if this is 30, guys, what is the walk going to be? You guessed it, 5 kilometers. And this is an example of one solution problem. It was kind of crazy, but I'm glad you stuck with it. Make sure to watch the video again or pause it at certain times if you're still confused. And that's how you do it.